Assalamualaikum and a very good day class. So, we will go now for week 2 online learning. We still under first order ordinary differential equation. But for this class, you will learn how to solve first order ordinary differential equation by using two types of method. The first one is separation of variables and the second one is linear equation. At the end of this chapter, you should be able to determine and find the general solution of separable equation, and also you need to determine and find the general solution of linear equations. So class will go one by one. First, we start with the standard form of a first order ODE. The definition for standard form for first order differential equation is given by the unknown function y is y prime equal to fxy. Or in this case, we can write dy dx, where this dy dx actually is y prime, which is equal to function of two variables x and y. To solve ordinary differential equation, there are three types of method. The first one is direct integration method, separable equation, and also the last one is linear equation. We were focusing on separable equation and linear equation, but this direct integration is introduction for how you can go to the separable equation and also linear equation method. The direct integration method, for example, if we have here dy dx equal to fx, if we want to solve this equation, means that we want to find a function of y. How to find this function of y? If you have here dy dx equal to function of x, means that we can write here dy equal to function of x dx. To get y here, you need to integrate both sides. Integrate this part, you will got here y of x, which is will be equal to integration of function of x dx. So that direct integration for solving this dy dx will give us y equal to integration of fx dx, where here y is the unknown or dependent variable, and then x here is independent variable, and solving here means that we find y as a function of x. That is here y as a function of x, which is given by integration of fx dx. Now we go to the example 1. Find the unit solution of the differential equation dy dx equal to 3x squared, which satisfies the condition y1 equal to 4. In this case class, we have the problem dy dx equal to 3x squared, initial condition y1 equal to 4. So class, by using direct integration, understood that from here we want to get a function of y of x. Y function of x. In this case, I can write dy equal to 3x squared dx. And then if I want to solve this one to get this y as function of x, I need to integrate both sides. Integrating both sides, I will have for this side y of x, which is equal here. Now we need to integrate 3x squared dx. So here, integration of 3x squared here will give us 3x, which is this one, 2, you need to plus with 1, and then you need to divide with this power, which is divided by 2 plus 1 plus constant c. So here we'll got here 3x to the power of 3 divided by 3 plus c, which is when we simplify this, we'll got x to the power of 3 plus c. So class, this is a general solution for differential equation dy dx equal to 3x squared. Remember here, given to you also condition y1 equal to 4. Means that in this case, you need to find the value of C as well because you have here the condition of y1 equal to 4. How to get this C? Okay, we have here y1 equal to 4. It means that x here equal to 1. This is the value of x. When x equal to 1, y equal to 4. So here I can substitute y and x in this function to get C, which is here I have y equal to x to the power of 3 plus c. So when I substitute y with 4 and then x with 1, I will got here 4 plus 4 equal to 1 to the power of 3 plus c. So now I solve this equation. I will got here c equal to 4 minus 1, which is 3. Means that finally when I substitute this c, okay, I substitute this c in this equation, I will got here y of x equal to x to the power of 3 plus 3. So this is a unique solution of dy dx equal to 3x squared. Now class, we go to this example 2. The question asks you to find the velocity of the car that is accelerating from the rest at 3 meters per second to the power of 2. In this case, we know that acceleration, when you learn in additional maths, is given by A. And this acceleration, actually it is equal, the relation with the velocity is given by A equal to dv dt. So from here, we can write here A, which is equal to dv dt. From the rest, it is equal to 3 meter per second to the power of 2. In this case, when we want to find the velocity, means that you need to solve this equation. Solving this equation, I have initially dv dt equal to 3. To solve this, I can write, okay, this is my equation. Step number 2, I can write dv equal to 3 dt. And then to get this v, I need to integrate both sides. By integrating both sides so that I can solve this equation, which is v at time t will be equal to 3t. Okay, you integrate this 3 respect to t, you got 3t plus some constant c. Now class, this is in terms of general solution. But the question asks you to find the velocity of the car that is accelerating from the rest at 3 meters per second. We have additional a point here which is mentioned from rest. When it is mentioned from rest, means that it is from t equal to 0. Means that when it is from rest, so the velocity here, the velocity when t equal to 0 should be equal to 0 because at initial it is not start yet to accelerate. Understand? It is not start yet to accelerate means that there is no velocity, which is velocity here equal to 0. From this, actually, it is implicitly in the question that given to us initial condition for velocity. So class, I can substitute here when I have v not equal to 0, this is t and this is v at time 0. I can substitute in this equation that is v at 0 equal to 3 times 0 plus c, which is equal to 0. This one is actually 0. So I will have here c equal to 0. Means that when I substitute this c equal to 0 in this equation, I have finally the equation of the velocity from the rest when the car is accelerating at 3 meters per second power 2 equal to 3t. So this is the unique solution of this problem. Now class, we go to this example 3. We have the problem of civil engineering where the bending moment M of the beam is given by dm dx equal to negative W L minus X, where here W and X are constants. The question asks us to determine M. Determine M means that you need to integrate this equation. And you need to determine M in terms of X. If given M equal to 1 over 2 WL square when X equal to 0. This one actually is initial condition. Okay. Initial condition of M. So class, what we need to do here, we have the problem dm dx equal to negative WL minus X. The first step you need to do is expand this equation. You will have here negative WL plus WX. So now, when we want to solve this one, we need to integrate both sides. So that we need to integrate dm equal to integration of negative WL plus Wx dx. So, in this case, this is integration negative WL plus Wx dx. I can expand this one. I can got here, you integrate dm, you got m, which is equal to integration negative WL dx plus integration Wx dx. So, class, when we solve this part, negative WL actually is a constant. Integrating this one, you got negative WL x plus integrating of WX here, you will got this one WX squared to the power of 2. But remember, need to add plus C. Okay, so now we have this one as our general solution. But we have initial condition which is given in the problem that M will be equal to 1 over 2 WL square when X equal to 0. So here, when X equal to 0, when you substitute X equal to 0 in this equation, this M you will need to substitute also with this term. So here we'll have here negative WL, when we substitute this one with 0, okay, plus W over 2 and then this x square, right? Means that x here you change to 0, so 0 square, okay, which is plus C. It will be equal to this M, means that equal to 1 over 2 WL square. When we solve this one, this part will got equal to 0. This one also equal to 0. So C equal to 1 over 2 WL square. In this case, when we have this C, to get the unique solution here, this for this M, in terms of general solution, you need to substitute this C with this. So that our final answer, M here equal to negative WLX plus WX square over 2 plus 1 over 2 WL square. So this is the unique solution, the final solution for this M when we have this problem with this initial condition. So class, it comes to the end of direct integration topic. Thank you class for your attention and I hope you understand this topic well. And let's say you have any problem, please do not hesitate to text me, message or ask. Thank you class for your attention. See you in the next video.